Welcome to this video on the Automic Automation AWS Batch integration solution. In this video, we will explain the AWS Batch integration and what it brings to the Automic Automation user community. AWS Batch allows you to run batch computing or processing workloads on the cloud. AWS Batch uses the advantages of batch computing and processing to remove heavy lifting tasks such as installing, configuring and managing computing software, and provides developers, scientists, and engineers access to large compute environments without human intervention. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic Automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic Automation synchronizes these processes with other, non-cloud operations. By integrating AWS Batch, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. AWS Batch processes can then be synchronized with all other environments routinely supported by Automic Automation, like applications and databases. AWS Batch role is reduced to submit the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the AWS Batch environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise them in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of AWS Batch jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: AE system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the AWS Batch endpoint and login data, and a job template designed to trigger AWS Batch jobs. Let's assume we're automating 4 instances of AWS Batch. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create submit jobs in Automic Automation for each corresponding process in AWS Batch. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in AWS Batch. We're able to retrieve the successive statuses, supervise the processes, and finally generate a job report. In Automic Automation, this submit job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the AWS Batch integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. AWS Batch is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. we create a connection object for every AWS Batch instance that we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the AWS Batch endpoint. Finally, we use the AWS Batch job template to create the jobs we need. We match this Automic Automation job to the AWS Batch submit job, reference the connection object, and run it. We're able to supervise the jobs, generate logs, and retrieve the status. The job can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the AWS Batch integration. The agent is included in the AWS Batch package, which we download from Marketplace. We unzip the package, which creates a file system agents/AWS Batch/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the AWS Batch job template. In our demo, we will create a connection object. Once we have established the connection to the AWS Batch environment, we'll create a batch submit job. Finally, we'll execute and supervise the job. Let's have a look at our AWS Batch instance. This is the job definitions view. Job definitions specify how jobs should run. They are the blueprint for the resources in our job. While each job must reference a job definition, many of the parameters that are specified in the job definition can be overridden at runtime. We also need to set up compute environments to be able to run jobs in AWS Batch. A compute environment is a set of resources used to run jobs. They contain the Amazon container instances that are used to run containerized batch jobs. Batch jobs are submitted to job queues, where they reside until they can be run in a compute environment. We can associate one or more compute environments with a job queue as well as assign priority values for these compute environments and even across job queues themselves. Let's log in to Automic Automation now. We add an AWS Batch connection object in exactly the same way as any other object in Automic Automation. Once we have the connection object, we can start defining it. The endpoint identifies the AWS Batch network address that we will connect to. The region defines the region in the AWS account in where Batch resides. If we do not define the region, the system uses the URL defined in the endpoint. AWS Batch supports different credential methods to access the AWS Batch environment: AWS credentials file path, EC2 profile instance, secret access key, and external provider. The AWS credentials file path requires the profile name and the path to the location of the AWS credential file on the agent machine. The EC2 profile instance requires the profile instance name with the credentials used for authentication on the EC2 server. This option is only available for users that already have an EC2 instance profile. The secret access key requires the access key itself and the corresponding encrypted secret. The external provider supported is Azure and requires authentication data to access the AWS system using single sign-on. First, we define the tenant ID of the Azure AD tenant and the authentication URL that identifies the network address of the Azure AD that we want to use to secure the application. Then, define the SAML username and password that we want to use for the SAML authentication. Finally, we define the principal ARN of the account's principal and the role ARN if want the user to assume a role. As mentioned, the identity provider supported is Azure. Let's have a look at the AWS Batch submit job now. Submit jobs are created in exactly the same way as any other job in Automic Automation. Once the job is created, we can start defining it. In connection, we select the connection object that we have defined, and that will establish the communication with the AWS Batch environment. In execution type, we choose to use either parameters or a JSON payload for the job definition. Both options allow us to define the parameters that we want to pass to AWS Batch for the job execution. Now, let's choose parameters to define the parameters that we want to pass to AWS Batch using the Automic web interface. As job queue, we define the job queue to which we want to submit the job. To select one, we can either enter its name here or click the browser button to open a dialog and search for it. The list in this dialog shows all the job queues available in the AWS Batch environment that we are connected to regardless if they are enabled or not. Remember that it is only possible to submit jobs to enabled job queues. In the job definition field, we provide the job definition that we want to reference. Here too, we can either enter it or click the browser button to open a dialog and search for it. The list in this dialog shows all the job definitions available in the AWS Batch environment that we are connected to regardless if they are active or inactive. We can reference an inactive job definition, but it should be active again by the time the job is executed. In the job name field, we provide the name for the job execution, which makes it easier to identify it in our AWS Batch environment. We can also use variables for the job name definition, which allows us to use the run ID of an execution as the job name if we want to. The container overrides field gives us the option to define properties in JSON format that will override the parameters of the reference job definition at runtime. In job attempts, we set the number of times a job should be retried, that is, moved to the runnable status after failing. In execution timeout, we define the time duration in seconds after which an unfinished job should be terminated. If you choose the JSON payload option as your execution type, you can pass parameters using either the JSON payload field directly or defining the path to the JSON file containing the parameter definition. If you choose the JSON payload option, you can also pass additional parameters to the job to replace variables set in the job definition. They are specified as a key and value pair mapping and override any corresponding parameter defaults from the job definition. The Details view provides detailed information about the execution, for example, the remote status. In this case, we see that the remote status is runnable. This information is updated along the job status on the AWS Batch environment and reflects the exact status of the job on AWS Batch at any point in time. You can refresh the page to see that the job has completed and that the remote status in the Details pane has been updated to succeeded. Let's open the report. Here we have all the logs. The agent log provides all the status information. Let's go back to the execution view. In the Details view, we can also expand the object variables to see the output variables published, which can be used in a workflow later on. Back in the executions view, we can also select an AWS Batch task and cancel it like we cancel any other Automic Automation task. The job is canceled also in the AWS Batch environment. When a task is canceled, the executions view displays the status accordingly. The remote status also displays the status of the AWS Batch environment, including the reason for failure in the status text. Let's open the reports once more. Here we have all the logs displaying the batch job status. The agent log provides the failed execution status and the reason for failure. Thank you for watching this video.